Right, I think we should probably kick off. Can everyone see my slide deck?
Yes.
Yeah.
Yes.
Good. Technology's working already. So I'm going to keep this a really short intro because I don't really want to eat into time we could be listening to Scott. But just briefly for those that are on the meetup for the first time, haven't necessarily attended before because it's now remote. We're a .NET meetup, obviously. We're focused on .NET technologies and everything kind of around it in that space. We've had lots of good talks over the last couple of years, which we've been running. Sort of goal before COVID was, developing a local community of developers come together once a month to meet up, have a few drinks, learn from one another, try and sort of get local speakers in mixed amongst sort of names that are sort of more out in the wider .NET sort of arena. So we're always looking for new speakers, always looking for sort of people that want to contribute and share something that they've done, some technology they've worked with. And you can always reach out to me on Twitter or message the .NET Southeast Twitter and we'll sort of get hooked up. And if you want to come along, that would be absolutely fantastic. Thanks to the regular sponsors as well. So we're not in the Magix office, but we're still using the Magix Zoom account to run these events. We've got our JetBrains sponsorship, although we won't do the prize draw because I've yet to figure out how that works after last month's attempt. So we'll figure how to distribute that somehow. Manning, who provide the discount code for us, and obviously the .NET Foundation as well for helping us with the meetup.com account. So just before we get started, a few Zoom tips. So encourage everyone to keep the cameras on. If you have cameras and you've got a clean background and a not too crazy haircut, we'd love to sort of see everyone as we kind of do the session. Keeps it a little bit more sort of social. While the presentation's going, if you could make sure you're muted, I'll sort of mute everyone when we kick off, but just make sure you sort of keep muted if you can. It's usually easiest to save questions for the end. I mean, if Scott, if you want to take questions during, that's fine, but if not, we can sort of do any at the end if there's time left over. We sort of treat this as everyone may be at home, so you may have kids around, so we'll just try and keep the language to good standards. And if anyone's having any issues or we get any Zoom bombing, that kind of stuff, then ping me and I'll do what I can to boot appropriate people out. Otherwise, I'm going to hand over to Scott. Really sort of great that Scott was able to kind of get this set up with us. You have a very busy schedule, as particularly after build, you must be sort of probably quite exhausted, but I'm sure everyone's really excited to kind of get all the recap and just kind of sort of get everything back in their mind as to what's coming up for .NET and sort of Microsoft in the next year or so.
Cool. Let me share my screen. Okay. So I thought I would do first off, folks who don't know me, I'm Scott Hunter. I'm the Director of Program Management at Microsoft on the .NET platform. I've been at Microsoft since 2007. I joined the ASP.NET team back then, and then over time, the roles changed quite a bit. I moved to Azure with Scott Guthrie in 2010, and did a lot of work with ASP.NET in Azure in that time frame. I came back to Developer Division. That's where we build .NET and Visual Studio, a family of products, around 2016. And today my team builds all of the .NET frameworks and core and tools and all that kind of stuff. So I wanted to chat today about kind of the journey to what we're going to call One.NET. And what I want to do today is I'll go through some slides, do some demos. I will admit some of the demos are a little faked. When I did some of the build talks, we had 5 machines. Today we only have my 1 laptop. And so some of the demos are videos because it's too hard to get 5 machines hooked up to Zoom. And some of the demos require crazy anatomy work on the laptop to make it actually work. So let's kind of start with that. So I'll skip this. This is Beth's my marketing person slide. It is kind of cool though, because when I joined Microsoft in 2007, desktop and web were really all that we had, and we've added cloud, mobile, gaming, IoT, and machine learning over the last couple of years. So the platform has gotten a lot broader. People always ask when I come and talk someplace, what is the how healthy is .NET? And we think we're doing pretty good. In fact, this slide's actually now out of date because Stack Overflow updated their developer survey yesterday. But we have more than 1.5 million active developers with .NET Core. .NET Core really shipped in 2016, but the tools didn't show up for Visual Studio or VS Code until 2017. So I don't think it really existed till 2017. So it's about 3 years old. And to put about 1.5 million into it in 3 years is we think is pretty good. Stack Overflow, as I said, just updated their survey. ASP.NET is the most loved web framework, actually, ASP.NET Core, even over React and Vue and Angular, which makes us very happy. And .NET Core was the most loved framework as well. So we're in both the web and the framework categories, we did really, really well. We only open sourced in 2014, which is crazy. When I joined the company, I remember working with Scott Hanselman and Phil Hack and Damian Edwards, and we all had this dream of cross-platform open source .NET. And in our positions at that time in Microsoft, we didn't think we could make that happen, but we did. And now we are one of the top 30 highest velocity OSS projects in GitHub. We've taken over 100,000 PRs in the .NET product line since we open sourced in 2014, and that's accelerating. We're one of in the top 5 languages on GitHub. The Tech and Power benchmark, which is the public benchmark, we are 7 times faster than Node.js. We're faster than Java. We're faster than pretty much any full stack platform. There's crazy frameworks up there that can beat us, but they also can't run general purpose stuff. And there's a whole bunch of work happening in .NET 5 that we were just showing to our bosses yesterday, where regex performance is 10 times to 100 times better. We're going to be better at the JSON Tech and Power benchmark. We're better at the Fortunes, which is the one where we're actually making database calls and all that kind of stuff. So there's a whole bunch of perf stuff still coming. And then when we do surveys when people download .NET and ask, who you are and why are you using our product. And we're seeing an influx of new people, a lot of students into the platform, which makes us happy. All up .NET, we added 1 million developers last year in 2019. And thinking that we're an 18-year-old framework and we can still add 1 million users a year, we are on track to add 1 million this year as well. I think that is super healthy. Of that 1 million, you can see that 600,000 of those were .NET Core developers. And I think you'll see that the .NET Core, .NET 5 aspect will continue to drive more as we move forward in the future. And then, one of the goals of .NET Core was to be available on Linux. And we saw last year more than 1 million publishes to a Linux image using our SDKs. And that's showing people are actually doing publishes and actually running our tech on Linux, which makes us very happy. Another cool thing, which is, a group like yours that's been talking about .NET for the years, .NET historically, it took our customers 3, 4, 5 years to basically move from a version of .NET to the next version of .NET, say a 3.5 to 4 or a 4 to 4.5. And that's because people mainly did those on hardware upgrades. They would wait till their office or their servers were upgraded. One of our goals with .NET Core was to get the thing moving faster. We don't want to actually have to support, a 10 or 15-year-old version of .NET Core. And so with .NET Core 3, within about 6 weeks, 75% of all of our .NET Core customers had at least tried .NET Core 3, which is unheard of for us to sit there and say within less than 2 months, everybody had kicked the tires. And I think that's also because .NET Core is side by side. Anybody can install it and try it without wiping out a .NET Core 2.1 project or 2.2 project. And so I think that's part of the reason for that, and we'll continue to push there. I'm sure folks, we're all developers. We use Stack Overflow. Just a few weeks ago, they completed their migration to .NET Core 3.1. And they saw, better performance, faster development, and easier being able to make containers easier. My favorite one is there's a tweet somewhere out there in Twitter from Nick Craver. When they the first day they booted up the entire platform on .NET Core, their test suite started failing the site. And that's because the site was responding so fast, the test suites thought it was an error. And that was an example of them seeing the perf of .NET Core increase. We see the same thing inside of Microsoft. We have a variety of services that are slowly moving from .NET Framework to .NET Core inside of Microsoft, and they all see these same benefits. Most of the benefits people see is memory reductions by 50%, CPU reductions by about 25%, and then depending on what the app is, you might see a much better perf as well. So at Build, we wanted to start with talking about what new are we making available that day. And the main things that we're making available that day was Blazor WebAssembly. So we shipped our first version of Blazor September of last year, Blazor Server. But a lot of our customers have been super excited about Blazor WebAssembly. And this to us enables what we call full stack web development with ASP.NET Core. You can write the front end, the back end, all the bits in .NET Core. With WebAssembly, for the first time ever, you can now run C# locally in the browser. Even we use this ourselves. If you go to try.dot.net, that's a website you can actually go to and actually run .NET code in the browser. When we first launched that, we actually were sending all your code to the server, running it on the server, and then sending the result back. And it created quite a large Azure bill. And we switched it to Blazor WebAssembly, and our bill went down to like $6,000 a month for thousands and hundreds of thousands of people trying it. Because of WebAssembly, it's the first time you can really build a real awesome progressive web app, because now you can actually, without having to write a lot of JavaScript, because now you can actually run C# in the browser without a network connection, fully supported. And this is now included in the .NET Core 3.1 SDK that was made available during build. If you have Visual Studio and you upgrade to Visual Studio 16.6, it'll automatically bring that version of .NET Core SDK with it and enable that. I might do a demo of that in a little bit, but I want to get through some of the slides first, and then we'll go back and do some of the demos. We shipped, as we did 3.1, 3.0 and 3.1 of .NET Core, we kind of signified to our customers that we don't plan to port any more parts of .NET to .NET Framework to .NET Core, so it's the last one. We did bring WPF and WinForms over to .NET Core, and we did that because there's still over 1.5 million monthly developers every month building WinForm apps and WPF apps with .NET. And so that seemed like a pretty large base. I heard just yesterday that we already have about 150,000 people building those same types of applications on .NET Core. That was what we were talking about yesterday. With the 16.6 release that happened to build, now you can go to on the Tools Options menu, and there's a checkbox to enable the preview WinForm Designer, but the WinForm Designer will be on fully in 16.7. 16.7 Preview 1 shipped the same day at build as well, and it brings most of the controls back. 16.7 Preview 2, which will ship in a few weeks, will be the end of us bringing controls back into the designer. And then after 16.7, we will try to get the third-party controls from all of our partners running in the platform. Another thing that we shipped to build is Model Builder. And so we RTM'd the last build, ML.NET, which is our machine learning AI framework in .NET. It's actually a framework used inside of Microsoft for the last 15 years, actually. It powers things like Windows Hello. If you have a laptop that lets you open it with your face, that's actually using ML.NET to power that. A lot of the features in PowerPoint that suggest slides and styles and stuff like that, that's all powered by this as well. But Model Builder is pretty cool because it really takes machine learning and enables it for people that aren't machine learning experts. And we added a feature in it for the release of build where you can actually train in the cloud as well. So if you don't want to have your machine run for a week to train your model, you can now upload the contents that you want to have trained into an Azure Storage account, and we can run all that in the cloud much faster. And that is a demo I will actually do. So I'm gonna jump over here. Let's find the right one. This is an app that we showed it in our long session at Build. We didn't show this in the short one. And this is actually a Blazor WebAssembly PWA style application. And the idea was it would be an app that you might use if you are working at a car rental facility and you want to check a car in when a car comes in. So let me log into it here real quick. There we go. And this app supports disconnected mode, connected mode, all those types of things. But in this case, you drive up in your car, I look up your license plate. The demo actually, and I think we're gonna make this code available on GitHub. The demo does show you that you can take Blazor and easily use a JavaScript library. I'm using a JavaScript library to draw the car and do all that 3D rendering. But I can come click on the door here, and you know, you can see this car was not brought back, looking good there. But we could have a feature where, as the person checking in the cars took pictures of the car, we use machine learning to go figure that out. Notice here it says, hey, it's perfect, it's not damaged, and we will leave 100% that it's good. That's because there's no machine learning here. So what I can do is I can go back to this app, and I can right-click. This is Model Builder. It's just in the builds now. I can click machine learning, and we've had previews of this for a long time. We try to turn all this into text that makes sense for you. In this case, I just want to do image classification, and so I'll click that, and I can decide to do local training or remote training. I'm going to do remote, and what that'll do is it allows me to go and hook up my Azure subscription. And I've got one of these already done. There it is. And now it wants a machine learning workspace and wants a set of compute resources. And I would click create. And now the next thing is, I know I want to do image classification. I told it I want to train it in the cloud. Well, I need to give it some data. So I'll click here. And all for data, all I've got to do is give it a folder of images. And so for builds here, I've got this car damage train. It's got a damage folder and a not damage folders. And there's basically 920 images of cars that are good and cars that are bad there. And I can click OK. And you can see here, it's going to let me look at some of those images. Now, what I can do is my next step is to go and train the model. And if I click start training, what's going to happen is it's going to go take those images, upload them to Azure Storage, and then run them in the cloud. Obviously, I'm not going to do that on the call, so I'm going to click out of this Visual Studio. I'll go back to this one. This is one that I've already done. Run that step in the cloud. And my next thing is I could evaluate here, and I could actually drag images in if I wanted to, and it'll tell me whether they're success, you know, whether are they damaged or they're not damaged. So I can try it here right in the tool. But what I really care about is this step, which is I want to go add some code to my project. And when I did that, what happened over here was it added a console app where I can try the model, and it actually added the model. Now what's cool is I can basically go and take this app and very easily add that machine learning to it. So let me go dig into this thing and see where I stuck that stuff. Okay, so you don't want to watch me write a lot of code, so I'm just going to uncomment the car checker model. And what I had done before is I just actually hard coded. I just want to show you how little code this is. One line of code. All it does is takes the model, it calls predict, and this is images, so I have to pass a path to an image. From that, I get a result where basically instead of returning is damaged false, I can actually return is it damaged, and instead of saying 0, I can actually return a score. So literally that's what 1, 2, 3 lines of code to go make that work. I can run it again. And now that same code that told me it was not damaged should tell me it's damaged. Let's go with that same car up again. Let's find it. Let's click detect damage. And now it shows 99% confidence that that door is damaged. So it shows you how easy machine learning can be with .NET. These are areas that we're going to continue to invest in a lot more in the future as we move forward. So let me go back to the slides. And at this point, we've at Build we had talked about all the stuff that was new for the 3.star product, and really our message to .NET developers and the message I want you to give all your friends and teammates that work on .NET is, if you're going to build a new project, we think the .NET Core 3.1 is what you should be doing. It's got long-term support for 3 years. We brought WinForms and WPF to make it easy to move your projects. You get that full side-by-side support, and you can now build self-contained exes, and we'll talk more about those in a little bit. And you got modern web UI with Blazor, both server and WebAssembly, and a bunch of new C# features. So we're very happy with that product, and we think it's a great time for .NET Framework customers that have not thought about Core. Now's the time to think about Core. I have a slide here because one of the demos that we didn't show at Build was we actually have some of these third-party vendors have WinForm designer support for their products in private builds that we have. But all these companies, DevExpress, Infragistics, Radzen, Grave City, Progress, Telerik, and Syncfusion, most of them all have Blazor components to plug into your Blazor projects, and most of them are working with us to have support for their controls in the new WinForm designer that's about to RTM. Now, this is kind of fun to me, is that we have this what we call Journey to One.NET. And I laugh at myself because when I joined Microsoft in 2007, we did already have a lot of .NETs. We had .NET Framework, we had Silverlight, there was a weird variant of .NET for phones, there was micro version of .NET, there was the .NET for some of the handheld devices and stuff we had back then. So we built a lot of .NETs, and I kind of like to make fun of myself because it's like, well, obviously Scott Guthrie got promoted by making a lot of .NETs, and so as a Scott, to get promoted, I need to make another .NET. So I made .NET Core, but that's kind of a joke. What .NET Core really was in 2013/14, we looked at the landscape of technologies, and we knew that .NET had to change considerably. It needed to be smaller, faster, cross-platform, open source, and you can't really just go take .NET Framework and do that to it. So we made another one. And our goal with what we're calling One.NET is to also take the Mondo Xamarin Tech that we have, which feels .NET-ish, but it's partially there. We want to merge that together into .NET Core, and the outcome of that will be .NET 5. And so we kind of merge these things together. And the vision here is single SDK. And so that means for any of those workloads I showed at the first slide, whether it's desktop, web, cloud, machine learning, IoT, mobile, gaming, there should be one SDK. And a lot of folks, as we have done our journey through .NET Core, Scott, you keep adding more frameworks to .NET Core, it's going to get bigger and bigger. No, it's not. As we go through this one.NET vision via .NET 5 and .NET 6, when we're in .NET 6, the .NET SDK will build console apps and class library apps and nothing else. You'll basically have a mechanism to say .NET add ASP.NET, or .NET add mobile, or .NET add desktop. So we actually want to make the entire SDK componentized. And the hope here is then third parties can also use that to be first class in the product as well, like other ecosystems. We want to have one BCL. You know, most folks don't think about this, but if you're building a Xamarin app, you're using the Mono BCL, which is not the exact same code as the .NET Core BCL. So at the end of this wave, no matter what type of app you're building on .NET, they're all going to use the .NET Core SDK BCL, and that's the base class library. That's strings and dates and thousands of APIs that are in .NET. And we want to have one unified toolchain, which means that all the projects are using the new simplified project system. Everything can be done via the command line, and the goal is everything works the same way. We want .NET to have awesome cross-platform native UI, and we'll talk a little bit about that in a few slides. We want to have awesome cross-platform web UI. We talked about Blazor, both server and client, and PWA. Our hope is to even go further than that. I'm sure everybody's aware of what Electron is. We want to let you build Electron-style Blazor apps in the future, where your Blazor app has a native shim that hosts a web view, and then your Blazor app runs inside of that. So whether you want to build native UI with the controls on the platforms or build web, we want to give you awesome choices for both of those. And we can do that Electron-style thing in a much smaller memory footprint and a much smaller disk footprint than you can with Electron today. And then, we've all, at this point in our lives, we've all heard microservices and containers and Kubernetes and Docker and all that kind of stuff. And so I want to talk about what we're going to do to make .NET even better. We've been working in this space for a while, but we have a lot more exciting stuff coming to think about there. And then, of course, we're always continuing to improve speed, size, performance. I like to think, to me, .NET Framework 2.0 was the high point of .NET Framework. It had awesome support for desktop. It had awesome support for web. It had awesome support for services. Of course, it's using older tech that most of us probably don't want to use today, but it was a pinnacle. It was one of the only platforms that could do all that stuff in that era around 2005. And I think when we end this journey in 2001, we're going to be back there where all those workloads I showed in that first slide all work awesome with .NET and are good or better than any of the competing tech. So let's talk about cloud native investments. There's 4 things here, and we'll do a demo of 3 of them. 2 of them will be videos, 1 we'll do live, and I have another demo here we'll do afterwards as well. But first thing is, I talked about Linux earlier, and more people are using .NET to build on Linux. We want to make building on Linux amazing, even on a Windows machine. So we just shipped Windows 10 2004 yesterday, and that's the version of Windows that ships with WSL2. WSL2 is the Windows subsystem for Linux, and you can run Linux natively on Windows with awesome perf, awesome compatibility. And so what we're going to let you do is we're going to let you basically control F5 and F5 into WSL. So it means the inner loop for building a Linux app is just as fast as the inner loop for building a Windows app. The next thing is, I think it's a little BS, but there's this notion that .NET apps or .NET Core apps are too big. And so, or maybe too many lines of code. And so there's a couple things we're going to work on here, which is we have a linker that we added in 3.0, let you link a .NET project to have less of the framework. All the stuff you're not using, we can link out. We're making a lot of improvements in that in 5, and we'll keep making improvements in that, and I'll show you some of the benefits of that in a little bit. The next thing is, if you're building something in Node or Java, you can build a single file app with little ceremony. And so we're looking and investigating C# features that let us do the same thing, and we call these top-level C# programs, and I'll do a demo of that. And then the bigger thing, which is probably the most exciting one here for me, is Project Tide. And this is, .NET's great, and the Visual Studio family of tools is great at building a single app. But as soon as you want to build a front end with 2 back ends and maybe a Redis cache or a Postgres database or a SQL database, the tool chain doesn't work as good. And Project Pi is the beginning of an experiment which will turn into something that will ship in probably in .NET 6 to solve that. And so with that said, I'll skip that and let's do a couple of these demos. And I'm going to cheat, as I said, and do a video here and there because I can't just go make my machine do something else. So this is a C# 9 demo. These bits are not available yet, but they will be soon. And I've got one file in here. And notice when I have my VS up here, there's using system, console write, hello world. There's no main, none of that goop. And if I want to, I could even kill the using system here and just stick that system dot in front of the console. But first off, let's run it, see that it works. I'll nuke that. And now literally I have a one-line C# file that runs and works. And so this will be a feature I said shipping in a preview soon. That's kind of cool, but I can do better. When I was hacking with this, the first thing I did is went to my CS proj and I added .web to turn this into a web project. And then I go back over into program CS and I'll nuke this and wipe out the white space here. And now I've got a ASP.NET Core microservice in under 20 lines of code. And I could even do white space stuff to make that even less, but this is spaced normally 20 lines of code to build a microservice. You know, .NET years ago would be hundreds of lines, and you can see it runs and works and it's great, and it does just what I would expect. And this kind of shows how we're trying to simplify some of these scenarios where you have less boilerplate, less ceremony in your application. Now, let's close that out and we'll go to a real video or a real demo. And I want to show the improvements we're making with the linker in .NET 5. So what I've got here is I've got the new Windows terminal. And in the Windows terminal, I've got a single file 3.1 folder, and I've got a single file 5.0 folder. And all I want to show here is I can, and what I'm doing here is I'm publishing, because I'm going to do a single file, I need to give it an architecture, so Windows 64-bit, and I tell it I want to publish trim. This works today in .NET Core 3.1. I'm going to run that. And as that runs, let's jump in on the disk over here. And just finished. And you see the resulting output of that is roughly a 45 meg microservice. .NET Core is over 100 megs on disk, so that threw away about half of .NET Core. But we do know that people think this is important. So here it is running on .NET 5. Same thing, architecture, single file, published trimmed. And while that's running, we'll go back over here. Jump into the bin folder, release. And look at this, 17 megs. So we took what, roughly 30 megs off of that in .NET 5. And so you can get to the point of being able to build a real microservice. And let's just let's go build. Let's go show the. There we go. I want to show it's real. So there's the 17 meg file. There it is running. And if I grab that, I'm pretty sure that my browser will run this application. So that shows that we were able to get a microservice down to under 20 megs in .NET, which I think is exciting. I think folks will enjoy that. To me, it's a vanity metric, but if people care about that, then it's kind of important. So let's do one more video, and then we'll go back to a live demo again. This is a demo of this. So what I'm going to do here is create a new project, and this is going to show WSL2. And I'll press next there, and we'll call this Web App Linux. And we'll create that, just do a regular web application. I could have made Docker, enable Docker right now, but I don't want to, because I want to show that I can run Linux without Docker. These bits will be out soon as well. And so this is just a regular app. I'm going to go into my index.cshtml. I'm going to add an H2 here, and then we'll write a little C# that will actually blast out the OS version. And so I'm going to run this in the tool because I want to show it's running on Windows and does typical Windows stuff. Windows NT 10.0 blah blah blah. That shows I'm running on build 2004 actually. And what I want to show now is if I go to my IS Express dropdown, notice there's WSL2 is down there now. Windows subsystem for Linux 2. And with that, I can just select that. And now I'm going to select some accept some certs. And it's going to run. And notice how fast it launched here. It launched in about the exact same time it launched on Windows. And now I'm running on Ubuntu. And so, and it's not just that I'm running, running it. I can put a breakpoint on that C# there, run the debugger, and we'll run the debugger all the way from Windows into WSL2, and you'll see the breakpoint will hit there, and things just run. Not even that, we've also taken, even though we've had Docker support pretty much since the beginning of .NET Core, we've improved it immensely. So if I go and add a Docker support here, and I'll do Linux again, Docker for Desktop now supports WSL2, which means Docker is much faster as well on Windows. It used to be we added a bunch of stuff. Now there's just a single Docker file. So we've really cleaned up all the junk we injected your project here. I'm using Buster Slim here as my SDK. And then what I do is you notice here, I also do a from on my SDK. So I'm doing a multi-stage build here, where I'm using one to build it and publish it into one that only has the actual runtime. And while I was doing all that, in the background, it was actually building the first version for me. So when I decide to Control F5 it happens very quickly. Let's click yes there and there. That's why this is a video, by the way, is there's cert problems with .NET 5 Preview 4. And there we are running on Unix again. This time we are running in containers. I can go to and do Docker ps-a, and you see it's running right there. And so this just kind of shows you the improvements that we are making with getting your apps to run on Linux. So let me close that away. And while we're waiting for that, boot up Docker Desktop on my machine, and I want to show you Thai, which I think is one of the most exciting things that we're doing in this space. And we will not do that while we're on the call with you folks. Let's wait for this to come up. While I'm waiting, what I'll do is I'll jump back to my command prompt, and I've got an app here. I'll load VS Code for this one. And what this app is, and it shows, it kind of highlights the problems that we have in .NET, these microservice style projects. If I close this thing out a little bit, you'll see I've got a front end app, I've got a back end app, and I'm going to delete that. There we go. I've got a front end app and a back end app here. If you want to run these in VS Code, well, good luck today. To run this in VS Code, what you're going to do is something like this. You're going to run the front end, and you're likely to be like me. You'd forget to go run the back end, or if you run it in VS Code, it would only run one of those projects. So I go and paste this into my browser. And then, of course, this is not going to be happy because I didn't start the back end. What I'd have to really do is go back over here. And do a .NET run over here. If you're in Visual Studio, what you could do is you could go right-click on the solution and tell it to start multiple projects at the same time, and that would be slower and not good. Now that I've got the back end and the front end both running, you know, the app will hook up and do the right stuff. But that experience is, I think, is terrible. So, and there's a whole bunch of other problems here too that we're not even talking about. So let me stop these. And let's talk about Thai. So with Thai, I can do something different. I can just say Thai run. And what Thai is going to do is it's going to go look in the subfolders of this and find all the CS proj files are in there. And when it sees those, it's going to start up the app, each app that it finds. And it actually is pretty cool. It's going to give me a dashboard, which is even cooler. Once you're running a multi-app, you really need something to let you know what's going on. So here I am. And what couple cool things have happened here is, first off, you can notice in the dashboard, it's got the front end and the back end. So it went and got the names from the projects. It knows their CS proj projects, so it calls them projects. And you see it points to the CS proj. The cool thing about the dashboard is I'm running multiple apps. Now I have the ability to go and look at the log for that app, look at the log for this app. Maybe I want to see the perf counters for these apps. I can click these and get some of the diagnostic details that we ship for the apps. So we're giving you access to a lot more stuff. And then, of course, I'm going to give you the URLs for all those running apps. If I click one of those, what's going to happen is it's going to fail. And this is one of the problems you have with running multi-apps in Visual Studio Code today is ports. So let's go back to VS Code and let's go look at the my CS proj file first. And what I'm going to do is I have this is a package you have to add today. Once we RTM this stuff, you shouldn't have to add this. But it's basically an extension of the configuration system for Thai. And so let's go look at our startup file. And what I would normally do with these types of apps is I would hard code. I might hard code a URL. So the front end app here needs to know how to find the back end app. So I've hard coded this URL. And you might be telling me, well, Scott, you can just use configuration files. Well, those configuration files are great for local development. But then you go run it inside of a Docker container and the ports all change again. Or you decide to go run it in Kubernetes in the cloud and the ports all change again. This is actually a problem. We should not be putting these ports in our code. So what I can do here is I can comment that out. Go here. And I'm going to uncomment this line. And what happens with Thai runs, for every project it finds, it goes and injects an environment variable into that project with the IP address and port the app is running on, which means instead of doing all this goop, I can now just say configuration get service URI and give it the name of the back end, because Thai is going to take the back end, the front end, and inject all those environment variables to all the projects, all the processes running. And so now I can just name these things by the names of the projects and not worry about all those ports happening. So if I save that, and we come back over here and we restart Thai again, now that front end project is going to be able to figure out dynamically the IP address of that backend project. So I can come back over here and we can refresh the dashboard. And now, if I click the front end, it's going to hook up correctly because it now knows how to find the IP address and the port of the backend. So that's pretty cool. Now, I'm building an app like this. As you're building an app today, you might need SQL Server, or you might need Postgres, or you might need MySQL, or Redis, or any of those types of things. Well, what would you do? Well, maybe you install SQL Server locally, or install Postgres locally, and then hope all the other developers in your team do the same thing. You could also boot one up in the cloud and use the one in the cloud. But with Thai, what I can do is I can go back to my command prompt, and I'm going to say Thai init And what that does is that will generate the configuration that Ty is dynamically inheriting for me as part of this app. So if I go back to VS Code, oops. If I go back to VS Code, now there's a Ty YAML, and you're going to notice that it shows you exactly what we discovered. We discovered that you have a front-end CS proj and a back-end CS proj, and we give them names. And that's how that port mapping stuff works. Now, the cool thing about this node is I can do other things here too. I can go and do something like this. Let's just grab this and stick this in. And so what I just did is I basically added 2 more projects or services to my Ty. I added one called Redis. And in this case, instead of viewing a project, I gave it an image. That's a container image. And it will go out to the container registry and find that Redis and grab it on my local machine, and I'm good to go. I then tell it the port, and I give it some config stuff to set up, and I'm good to go now. I didn't write any Docker files. I didn't run any Docker commands to pull stuff locally or any of that kind of stuff. I just went to this simple configuration file and pasted this stuff in. Imagine us giving you IntelliSense for these things as we go forward. Now, once I do that, all I've got to do over here is run Ty run again. And now what's going to happen is we're going to boot up both the front end project and the back end project. But you're going to notice as part of that as well, we're going to go boot up those containers. It would help if I save the file. So it's now going to go and not just boot up those 2 processes. We'll see some, there you go, creating Docker network type. You can see the containers that we're running there. And now if I go back to my dashboard again, and I refresh, now I have 2 more projects here. And notice that the project, the type not being project anymore, their type is now container. We know those are containers. There you can see running on the port that I asked it to run on. Over here, I can actually view the logs from Redis live in the dashboard. Now let's go back to our project and VS Code, and we'll add a little bit more stuff to it here. Let's go to the CS proj. I'm going to uncomment the line that brings in some of the Stack Exchange client stuff. Yeah, you can restore that. I'll go back to Startup CS. I'm going to add a little bit of code here that will configure the Redis cache and inject it into the project. Once again, notice the connection string. I don't know the ports, localhost, or any of that kind of stuff. I use that same environment variable injection that we used above, and I'm good to go. And then I can just go into my pages folder into index. And all I've got to do is I've got some code to uncomment here. And this code basically says that's a tag helper that creates a distributed cache node. Give it a name, tell it expires in 5 seconds. And this means that what's going to happen is when this page runs, we're going to stick the output of that tag helper into Redis, and we're going to cache it for 5 seconds, and all requests will come out of that cache. So let's run Ty one more time here. There we go. And I'll go back to my dashboard here. Let's reboot the dashboard. All these projects are running. I can now go to my front end application. If I keep pressing refresh, nothing changes. It just updated. It's been 5 seconds. It's been 5 seconds again. I can go to my Ty dashboard, as I mentioned before, and now I can see all the cache hits happening on Redis, all live in this environment. So we think this is going to revolutionize how you build microservices in .NET. And you can do other crazy stuff here as well. I could stop this, and I've been doing Ty run, but I can do Ty run -- help. And notice I get an option here I can run all of it in Docker. And so let's just do that. Tye run -- Docker. And this means we're going to run even the CS projects inside of Docker. So I'm running basically the entire thing end to end inside of containers on my local machine. And I never had to go create a Docker file or do any of that stuff. Of course, we're going to give you backdoors to go do those things if you want to manually do them. But our goal with Tye is to be able to run very complicated applications without having to do all that kind of stuff. So if I go back to the dashboard again, we refresh, now everything is a container. And of course, the app's going to work just like it did before. Boom, all of it's in containers. Now, why is that running all in containers important? Well, the other cool thing that I can do, we won't do it on the call, but I can come down here and grab this. We can go back into VS Code, into my Tye YAML, and up here, I could actually add that and save that. Now, I basically added the notion of having a registry, container registry. I gave it a name, and then back to the command line, there will be another command in Tye, which is Tye deploy. And so I can basically do Tye deploy now. And what will happen is we'll build containers for all 4 of those services, and we will then upload them all to that registry. And then if I had Kubernetes hooked up to that, Kubernetes in Azure will pull that registry in those containers. All the apps will boot up inside of Kubernetes. And because of all that port mapping logic, the ports are obviously going to change once they're running in Kubernetes. But with that port mapping logic, it'll all hook up, it'll all just run. And so this is Tye. And the goal with Tye is really to simplify the aspect of building these multi-project applications in .NET, making the ability to run some of the apps in containers or to use container images for services you need like Redis or SQL or Postgres, super easy. And you'll see us take this technology and merge it into Visual Studio, merge it directly in. Right now you're seeing it's the Tye command. It'll be in the .NET CLI in the future. Super excited about this. And so that's Tye. So let's talk about cross-platform native apps for a second. So we introduced something at Build that we're calling .NET Multi-Platform App UI. And Beth Matthew, my marketing person, is not here, so she can't complain when I laugh about this. We love naming things complicated, but we named it this way because it actually shrinks down to a really cool name, which we're calling .NET MAUI. And in many ways, .NET MAUI is kind of this. It's cross-platform native UI. It is a single project. If you use Xamarin Forms today, Xamarin Forms creates a project for Android, a project for iOS, a project for Windows. It creates a shared project to be shared between all those things. That's complicated. We want these cross-platform native apps to be super simple. And so single project, single code base for an app that runs on multiple devices. Once you have that single project, you can basically right-click on the project and say deploy to iOS, deploy to Android, deploy to Windows, deploy to Mac, and we'll just do that for you. It's an evolution of Xamarin Forms. As part of the One.NET kind of strategy, we want to take Xamarin and make it feel like it's just a native part of .NET. And so this is taking Xamarin Forms to the next level as part of that. You will see it later this year. Initially, it was going to be in .NET 5, but with COVID and all the stuff going on, we're being honest with ourselves. We think things are going to go a little bit slower. And so we're going to ship it in .NET 6, not .NET 5. You'll see an RC, or not an RC, you'll see a preview of it. The first previews will happen around the RC of .NET 5 in September. When we RC .NET 5, we'll open the branch for .NET 6. We'll stick the Tye stuff, we'll stick the MAUI stuff in there, the .NET MAUI stuff in there, and you can pull and try that. This is where it gets kind of cool. To make this thing feel like it's really part of .NET, notice here that we can do system.ui, system.devices to replace the Xamarin Forms namespaces, file new multi-platform app UI, and then .NET new MAUI. So it just feels like it's a natural part of the .NET platform. If you're a Xamarin Forms customer today, keep using Xamarin Forms. We have a major update to Xamarin Forms planned this year while we're working on .NET 5. And we will give you tools to make it easy to port your app to Maui when it comes out. Maui will obviously be the new project system. It'll be new namespaces. We'll give you a tool to help convert those things. And then also, we want to make the rest of the Xamarin Tech feel like it is more just part of .NET. And so what is Xamarin.iOS today will just become .NET for iOS. Xamarin.Android will become .NET for Android. The namespaces there will all stay the same because they're basically tied to the namespaces of those platforms. But you're going to see at the CLI, .NET New iOS, .NET New Android. Super excited about these. So this one is one that I have to do demos on video as well because we had different machines for each of those demos. So I've got 2 demos to show here. We'll show the Mac one first. This is on my Mac. And I want to show that you can do .NET New Maui. And so I make a folder here, go into the folder, .NET New Maui. That's going to build my Maui template for me. And we'll do a dir here or an ls just to go look at the folders. This is not using that new project system yet. And because it's kind of hacky bits, I'm going to do a new get restore. And then once I've done that, I'm going to launch code. And once again, you've never been able to build Xamarin style projects in code. This is new as well. Once it inherits our SDK, you can do everything inside of any of our editors. And I'm going to go to the main page here. And this is going to show some new stuff here. First off, look, there is no XAML. XAML is still an option, but this is using C# to define all the markup for the project. So I've got a Maui page. It's got a body with a navigate view with a VStack. All that stuff's there. Now I can even run this. So I'm going to click over here and select iPhone 11, 13.4. There's the iPhone emulator comes up on the device over here. You'll just take a second, and then you'll see the icon for my app appear directly in the emulator. And then I'm going to show you a feature we actually been shipping for a while. And this is hot reload and hot restart. So there's the app running. And I'm going to go to the UI. That's first, click a few times. Yep, it works. Now I want to change that. Let's change a few things here. So that thing should be center. So I'll just type center. I'm not even going to press save. As I press center and type that, the text just moves to the center. Maybe I don't like the color. I'll type pink here. It changes to pink. Yeah, I'm not really a fan of pink. I'll type black again, change it back to black. Now, I can also change some of the C# here. So let's go change the code here. I'm going to change the pluses to minuses so it goes backwards. Now, I'll just press the plus button down there and it goes backwards, but I'm going to change the plus button too. So I'll just go change this. Minus, now it's really a minus. And so this is showing a couple things, which is one, we want to have that ability to .NET New these applications. We want these applications to work on all of our editors. And we want these versions to have hot reload, hot restart. And we want to have the ability for you to choose if you want to use an MVU model using C# versus using XAML. That's an option. Now I'll show one more demo that we have in this case, and this is going to show File New, multi-app platform app UI in Visual Studio. I'll close that down, open an existing project, and now I'm back in what you would expect for Xamarin. Look here, it's all the XAML that you would always expect. It's got the XAML binding. So if you have skills today, you can bring those skills over just like you've always had. Things are just going to work. And so the idea here is, as I said before, we're giving you both MVU with C#, and we're going to give you the XAML for compatibility and familiarity. So now it's your choice. Now that I have this application, I want to show something else. Historically, I had to go run these on various devices. We want development to be super fast. I can just click to run on Windows now. Now it runs on Windows. So click the debugger, and Diagnostic Tools boots up on the right side of the screen. Here's the same looking app you saw before. I can click on it, it'll work. And so these multi-platform app UI apps, MAUI apps, .NET MAUI apps, easy to develop on Windows and Mac, defaulting to the local OS as the default experience. So that's pretty cool. Another feature we shipped for a while ago that a lot of folks don't realize is, once again, we call this hot reload, hot restart. I'm going to plug my iPhone into my Surface device here, and I don't even have to have I can take a free Apple developer account, no Macintosh at all, just plug my iPhone into the PC, and when I do that, if I drop down the list here, you're going to see my iPhone just show up. So I've installed nothing on the iPhone, it just works. I can go over here and deploy that to the phone. And what I have running is I have an app called Reflector that will mirror my phone to my Windows screen. And here's my phone, and my MAUI app runs just like you would expect. Free developer accounts from Apple, iTunes installed on your machine, Visual Studio, developed locally on your iPhone, no pay anybody anything, no Macintosh involved, awesome developer experience. So I'm going to close that out, and I want to talk about that single project. If you look on the right side in my Solution Explorer, I've got a single project here, just my app. And this app supports, you already saw it run both on Windows and on my iPhone out of one project. So what I can do here is click and look at resources. And now we have a special node in the project where you install your resources for all your apps. There's my .NET Pop icon. And I've got a bunch of TrueType fonts here as well for the app across all those different platforms. Kind of cool. The real cool node to me, though, is the platform node up here. Historically, as I said before, you'd have a project for Android, a project for iOS, a project for Windows. Now we've reduced all that down. If you open this node up here, you're going to see I've got a folder for Android, iOS, and Windows. And inside of that is where I would put any of my files or my C# code that is specific to that platform. So I can write Windows-only code in the Windows node, and that code will work just fine. But our goal here really is to simplify building these what used to be Xamarin Forms app, now .NET MAUI apps, into a single project, developed locally without any emulators, and easily bring all your devices and just plug them in and they work. And that is MAUI on Windows. So let me kill that. Go back here. So we have preview 4 of .NET 5 out right now, and you can see our goals here are basically, a bunch of cloud native improvements, Project Thai. We'll have a preview of MAUI out a little bit later this year. You can try .NET 5 today. I recommend waiting until preview 4. One of the reasons I was showing some videos is every time that I do some of those demos, like the container demos, there's a bug in .NET 5 preview 4 that destroys the HTTPS cert for ASP.NET Core, and you have to physically delete it with Cert Manager and start again. And so for doing demos with groups like you, I don't want to be going back to Cert Manager many times and nuking that stuff. That's fixed in preview 5, so I'd wait 2 weeks and get preview 5. A lot of folks along this journey of .NET Core, when we did .NET Standard 2.0 a couple of years ago, we enabled UWP developers for the first time to get access to all the .NET APIs they were familiar with and use packages. But when .NET Core 3 shipped, we got a lot of feedback is like, well, where's UWP? Why is UWP not on .NET Core 3? And we didn't put it on .NET Core 3 because we knew the Windows team was working on WinUI. And WinUI is the future version of UWP. It's Fluent XAML for building awesome Windows 10 desktop apps that use all the latest Windows 10 features. All the touch stuff is all there. It does have a lot of improvements over UWP as it is today, meaning there's no app container. The app can run on the machine with full access if you wanted to. It's X-copyable. You can just copy an app to the machine. You don't have to use a store to install it. And UWP had different features based on the version of Windows 10 that you were on. The WinUI inherits the same style that we're doing with .NET Core, where you copy the framework in your application. And so all applications have access to all the features all the time. It supports both .NET 5 and C++, and they have previews out available today that you can try. Always have to talk about our schedule. We've been saying this for a couple of years, but it's just now starting to sink into people. We ship .NET every year now. So we will ship .NET 5 this December, or actually this November. .NET 6 will ship next November. .NET 7 the next November, and then every other release is an LTS. And if you follow Node or Ubuntu or many other open source projects, they do the same thing. Part of our goal here is to be very clear to the customers. Here's the expectations. You get a new .NET every year. They're all side by side. Every other year is an LTS, which you can support for 3 years. So if you really want long-term support, just upgrade every other year and get your 3 years. And the goal here is really to be predictable. If you looked at us during .NET Core 1 and 2, we had releases 6 months, 9 months, a year, over a year. Nobody knew when they were going to come. And so we're trying to be way more predictable. We also have .NET Conf. This is our virtual online conference we do every year. And now these are going to end up being in November's, because they're going to be the launch events for these .NETs. And so this will happen in November 10th. That'll be the launch date for .NET 5. It's 3 days. It's about half my teams inside of Microsoft and about half the community. And it'll be the outcoming for .NET Core. Kind of our go-to message to our customers is, if you want to go build a brand new app today, 3.1 LTS is there. It's got 3 years of support. It's got tons of features. It is the version to move to for new applications. And if you want, try the previews of .NET 5. As I said, they're side by side. They won't break any of your .NET Core 3 stuff. But as you heard me say, wait till preview 5. And I think that is all that I had today when it comes to slides and demos. I'm happy to, I'll do one more fake demo before I go to questions. I mentioned before electronic kinds of things. So let's do this. Steve on the team, he's a vital part of the make sure I get the right post. No, let's go here. Steve is a vital part of the Blazor team. And here's a Blazor application running as a PWA. So it looks like a desktop application. As I said before, we could actually, what our hope is to be able to run these apps also inside of Maui, .NET Maui. So you imagine a .NET Maui app that can actually host a Blazor app. Then you've got a native app, say Electron style app, that runs a Blazor app. Now this is cool to us because, take a look at this. An Electron Hello World app today would be 66 megs and thousands of files. If we take Blazor and have a native shim that boots up a Edgeum web view, and we trim the app, maybe the app ends up being about 32 megs. Hello World's 32 megs, so it's half the size download. Well, we can cache the framework on the machine, which means the next app that you download would only be sub 1 meg. So we think this is kind of an exciting thing we can do. Now take a look at this. Memory-wise, if you're running a Blazor Hello World app, it's going to use 150 megs of RAM. That same app on Blazor is 19 megs. So we think we can get to a pretty cool point in the future where if you want to have a hybrid app that's basically a combo of Maui plus Blazor, we can get you into an awesome footprint on memory and an awesome footprint on download size and give you awesome performance. So this demo doesn't run right now on my machine, but I'll boot it up so you can see what this would look like. Let's go. Actually, back up one. This is a Maui app that hosts Blazor. And as I said, it doesn't run right now. But what you can actually do with this app, yeah. Imagine you have this should actually clean itself up in a second. You have a Maui app using Blazor style kind of syntax to define your app. But then inside of this Maui app, I can put a Blazor web view. And then inside of this Blazor web view, I can do whatever I want. I could go in here and HTML tags. I could write C# code. And then from that, I could do things like create H1s and put an I inside of those. So we envision this point in time that you can do some crazy stuff here where I've got my native controls, my web controls all in the same application. And because this is actually a native app, I can actually create processes, talk to native APIs, do all kinds of crazy stuff. And this is something you'll see us explore as we go into the .NET 6 wave. So with that done, I have talked a lot, and I will go to questions.
If people want to ask them directly, I'll hand over to you. And if you don't feel like talking, I'll read it out. But I know Gareth, you had a couple of questions in here.
Yeah, my first question really was about where Dapper fitted in versus Project Ti. There's a Dapper build video that I watched, and that looked pretty cool. But is this competing with it? It seems like a Micronettes type style project.
No, we think of, for Dapper, we think of Dapper being something that provides additional services to your .NET application. So, you know, Ti was just a way to run multi-project applications in .NET. Dapper is more about injecting capabilities into .NET. For example, imagine you have a Blazor server application. One of the limitations we have with Blazor server today is it needs to be stateful. And so you could use Dapper, and we have a demo that we have somewhere in the office where we use some of the Dapper tech to actually have the stateful store that we use for Blazor server. So if a node died, you don't lose the state of your application. Or if you want to scale to multiple nodes and requests jump across those, you're in good shape. So we see these things as a combo. Ryan, who used to be on our team, is now over in the group that builds Dapper. And so we have an ASP.NET person over in that org, making sure that ASP.NET and Dapper are going to fit super well together. There was a question about linker stripping down to bare minimums. What guards will be in place to handle reflection? So you will obviously be able to blow your foot off with the linker, and there's no way we can prevent that. It's been one of the biggest challenges most of our customers have with UWP today, is the same kinds of things. UWP uses .NET Native, which is a linker technology by default. Our goal is to hopefully give you a couple of tools. The tools we're investigating is, number one, is a analyzer that, as you wrote code, might tell you how much code you're adding by adding something. So you write a line of code. Imagine we told you, well, that's 3 megs. So we made it more apparent as you write code what the cost of the code was. That same linker could also, as you use reflection, put a warning into your system saying, be aware that you're linking your project, and because of this code, you better verify that you know, the library you need is actually loaded in memory as part of this. There are files associated with the linker where you can actually override anything the linker does, but it's our job is how do we make that better? We're going to call this a journey. You know, .NET Core 3.1 had single file that used a dirty trick. Basically, we stuck most of the executable into a resource. When you ran the application, we copied the resources to a folder and ran them. The stuff I showed in .NET 5, we actually ran them directly from the single exe. So we got rid of that decompress stage. In the .NET 5 stuff, I didn't show another feature that we don't have yet. We didn't have it for build. We're also going to let you compress that exe. And so you can actually get that 17 meg exe down below 10 megs with compression at probably no cost to performance, because the assumption is we'll do less I/O. It'll be faster. And we'll give you more and more tools to hopefully not blow your foot off. But for the people that really care about size, we want you to be able to make it small.
Thanks.
Can Project Tie to start multiple Azure Function apps locally? I think that would be a goal, yes. As part of Tie, it would be very cool if you could actually have a front end, 2 Azure Functions, a Redis, a back end in full .NET. That's all part of the thing we're trying to solve. Question for later. Will we get .NET native compile for WinForms, WPF, and Maui? Originally, that was a plan that we had in .NET 5. They got punted a little further out. There's 2 runtimes that we have in .NET today. There's the Mono runtime, and then there's the .NET Core runtime. The Mono runtime uses native compilation, and the .NET Core runtime obviously is JITted. We are going to make the Mono runtime available for all project types, whether that's WinForms, WPF, ASP.NET in the future. We just have to spend some time to harden it. It's primarily today, you know, even though Mono could build desktop apps or it could build web apps, it's never had the same kind of hardening that we've done in Core and .NET Framework over the years. And so when we were experimenting with it in .NET 5, it was not reliable enough for us for a, you know, like a tech empower benchmark kind of scenario. So it needs more time for us to harden it, but the eventual goal is, yes, to give you that. And yes, you should be able to use things like Prometheus. I was sidecarding in some ways Redis and another implementation of Redis. Question is, Tie using Kubernetes under the cover? Yes and no. It can. If you look in my if you look over here, I'm not sharing my screen anymore, so you can't see that. But I was gonna show you. I do have Kubernetes enabled inside of my Docker desktop, and I can actually run Kubernetes controls and actually run the app in Kubernetes on my local machine as well. So you can go all the way from just having some CS proj files that we just run to running some Docker files to running in Kubernetes. The whole gauntlet is available on your local machine with Tie. This is a great question. Project Tie's README says it's an experiment at least until November 2020. Is there a timeline for graduation? The timeline for graduation is probably going to be .NET 6, which will be November of 2021. The reason we call it an experiment is I showed a whole bunch of stuff. I showed dashboards and containers and running in Docker. I talked about you can run it in Kubernetes. I showed that there could be escape valves or hatches where you could actually supply a Helm chart or a Docker file if you wanted to. We're calling it an experiment because we need feedback from you in that project to let us know what needs to be in a 1.0. Right now it's an experiment because we're just trying to find out what people need. We are working with some teams inside of Microsoft that need this kind of tech. But we would love to have feedback from externals of what they think what's the min bar for a Tie. And so that's why it's called an experiment, because it won't be ready for .NET 5, but it will be ready next year. Has a decision been made on what flavor of Xen will be used for, I assume, for Maui, .NET Maui applications? Today it is Xamarin Forms XAML. That could change. The .NET MAUI stuff's not going to ship until next, it'll be shipping in part of .NET 6. So we have a year and a half to figure that out. I think .NET MAUI, we're assuming that we'll start doing public previews around February of 2021. It will be available for the adventurous people, it'll be probably available in September. To basically go and clone the repo and get, or actually we'll have Nightly's and get. So you'll be able to go to GitHub and just grab Nightly's in September. But I don't think it would be RTM-ish or really ready. Give us a couple months after we get 5 out the door to get there. But that said, we're working on .NET MAUI right now. The hope is to be really, really ready when September comes. Somebody's timer's going off. So will MAUI apps be able to be deployed to app stores? They will definitely be able to deploy to the iOS and Android app store because they are basically, the evolution of Xamarin Forms style applications. When it comes to the Windows stores, I think we need to see. We don't know yet because we're too early what the Windows UI technology will use. Whether that would be WinUI or WPF or whatnot. We're kind of waiting for Windows to get the WinUI stuff further down the road, and we can decide what we do these things on. But depending on where the Windows Store is, that would definitely be a goal to make that an option. Will App Center support MAUI? I would say yes. It doesn't today, but the ability of doing telemetry on a MAUI app, a .NET MAUI app, makes a lot of sense.
Thank you.
No store needed. So is Windows Store dead now? Windows, I'm not aware of any plans to get rid of the Windows Store. But even Windows realized that, Imagineer, even Microsoft, do I want to actually, if I want to go build an LOB app for my team, do I want to have to go through the Windows Store to make people install it? No. So I think they realized some of the requirements around UWP were too strict. And so WinUI is basically a UWP with a lot less restrictions. It's more your choice. Oh, this is a great question. Regarding ML.NET, how long did it take to train the 920, the 1800 images? It takes about 15 minutes in the cloud. On my local machine, it'll take a couple of hours, but in the cloud, just a few minutes. And in that case of training in the cloud, I only have to pay for that compute for that 15 minutes. So it ends up being fairly cheap. So is the WCL integration with VS coming with .NET 5 or part of the future VS 16.x release? It'll come as part of the future 16.x release. It will not have a dependency on .NET 5. And I would guess 16.8 would be my guess of when that will show up. But they hope to have a public preview that can be installed in 16.6 or 16.7 or 16.8 pretty soon. Those bits actually work really good. They're really solid. I can't tell you how fast they are. They are running a .NET Core app in WCL2 is just as fast as running it locally. I mean, it's amazing.
Looks like we've run out of questions. Does anyone on the call have anything they were burning to ask?
I apologize. I have to run off the call. I've got another Microsoft meeting that actually popped into me as well.
That's no problem. In that case, we'll wrap up there. So big thank you though for
thank
coming
you folks
along
for having me so much, and I hope you enjoyed it. If you have any questions you want to send to me, you can just find me on Twitter at CoolCSH, and I'm happy to answer anything. Anything I showed is you're welcome to talk about. There's nothing NDA there, so have a good night.
Thank you.
Have a good day. Cheers.
Thanks.
Let's go.
Thanks.
Bye.
Thank you.